Welcome back to my channel, Pharma-info with Shubhashish. Now today I'm going to deal with Azepine. So Azepine, how the structure will be. So if I just see the name Azepine, right? So it starts with Aza, right? That basically it corresponds to nitrogen atom, right? Ep is found to be the stem of 7-membered heterocycle. Heterocycle, right? Okay. So now so with this with the name only, okay, at least we get to know that it is a 7-membered heterocycle containing nitrogen. Fine. So how the structure will be, if I just create the ring. So this is found to be the 7-membered one, right? And we have a lot of unsaturation, okay, there inside the ring. Fine. So this is your Azepine, to be more precise one. So as only one heteroatom is there, so we must not be in a mess. So straightway we'll consider this as position 1, and it goes on like this: 1, 2, 3, 4, 5, 6, 7, like this. Fine. So as I said 7, because 7 seems to be the stem, right? Because the common syntax that we are using for this heterocycle, while naming a heterocycle, is the common syntax is prefix. It's a combination of prefix followed by a stem and followed by a suffix. This is found to be the common syntax of any heterocycle. Fine. So prefix, if I just write here azole, assume that, okay, apart from this azole. Fine. So azole is for what? Azole is Aza, prefix. It basically indicates what? The type of heteroatom that constitute the heterocycle. Fine. All means the stem. All corresponds to the ring size. So all means 5-membered, right? And then 5-membered, and E means, that means inside the ring you must find what? Inside the ring you must find the unsaturation. So if I just present a heterocycle which is a 5-membered, it is something like this. So this is pyrrole. So pyrrole is having a Aza, so likewise Aza. All means 5-membered, 1, 2, 3, 4, 5-membered, the ring size, and E means unsaturation is there, right? So this is found to be the common syntax that we are using, we are following, or we are basically following while framing the or while dealing with a heterocycle rather. Fine. Okay. So this is not okay. Let me just find some other time, right, so that we can this particular topic can be illustrated further, right? So now straightway let's see that what are the ways by which Azepine can be made, right? So this is Azepine. So Azepine means 7-membered heterocycle. Aza is there, so that is why the other means nitrogen is there. Fine. So now let me do one thing. Okay, we have a procedure in organic chemistry, so which basically deals with what? Expanding the ring system, right? So expansion of ring system means, so if I start up with a 6-membered ring system and my projection is to get a 7-membered ring system, so how things can be executed? Let's see. Fine. So Azepine can be produced. The first way of making, so this is found to be the first way, right? First way of making Azepine, that is the ring expansion, right? So here we are basically going to take what? Benzene. So benzene is found to be 6-membered, and our purpose is to make it 7-membered, and that to be the heteroatom, right? So here, so this one is benzene. Now here the reagent that we are going to use is nitrine. So nitrine is what? Nitrine is N3. When you observe that nitrogen is having 3 nitrogen, or any nitrogen molecule is having 3 nitrogen in it, so that is, and they are connected by means of a double bond, right? So this is basically now, and finally we have something like this. Fine. So as a whole we can say this is called as ethoxycarbonyl nitrine. This is ethoxy, this is carbonyl, this is nitrine. Fine. So N3. So this compound is called as ethoxycarbonyl nitrine. Fine. So this is the one with which I can expand the ring system, and with the carboxylate, with the ethyl carboxylate linked at nitrogen. Okay, fine. So from here, let me just do one thing. So this is okay, just to avoid any kind of confusion and all, right? So what will happen as a result of this interaction, right? Ring expansion will take place, and it is the nitrogen that comes from nitrine, right? That comes from nitrine. This is something like this. Fine. Okay, so this is the double bond, this is the double bond, this is the double bond, and here we have so, okay, CO C2H5, CO C2H5, that means ethyl carboxylate. So this came from this part, and this N3, that means nitrine, right? Nitrine is basically releasing one nitrogen atom, right? And this nitrogen atom has been placed, okay, inside the ring, right? And thus we got what? We got this kind of intermediate, fine. So this is found to be the intermediate one, right? So this is basically ethyl azepine carboxylate, fine. Now what next? The next is, once we got this kind of intermediate, right, this need to be treated with a base, right? Base OH minus, and here either you can take K plus or you can take Na plus, right? It is your choice whether you are willing to take sodium hydroxide or potassium hydroxide. So that is why I have written here, and it is the one that we are expecting from the base, right? So this, in presence of a heat, will produce our compound of interest, that is the one which we are looking for, that is azepine. So this is how the synthesis stands for azepine. So you can just also write 1H azepine, actually 1H, because at first position we have a solo hydrogen which can be given to the seeker, right? Fine. So this is all about the first way of making azepine, right? Now let's move on to the second way, right? The second way, right? Second way also is a kind of expansion, what we can say. It's an expansion, but here we are not going to make azepine, rather alkoxylated azepine, or we can say derivative of azepine, fine. So how this reaction goes? So here the starting material we are going to opt is nitrobenzene, fine. So this is nitrobenzene, okay. We all know about the structure of nitrobenzene. It is the nitro group which is placed at position 1, right? So this is nitrobenzene. So nitrobenzene in presence of what? In presence of a phosphine derivative. So phosphine is something like this. Phosphine is, now here I am going to take C4H9, C4H9 and H9C4. So this can be called as what? This can be called as because all are butyl, right? All are butyl. So thus we can write it like tributyl phosphine, right? So we are done with tributyl phosphine. You can also write it like this. You can also write it like it if you feel uncomfortable with this kind of presentation, right? So you can just write like this: C4H9 whole thrice, fine. So what will happen here? So initially what will happen, this oxygen will get eliminated, fine. This oxygen will get eliminated, and which basically leaving behind what? Leaving behind an intermediate and a nitrogen intermediate, fine. So the nitrogen intermediate is what we can say. So this is called aryl nitrine, fine. So this is the one that is getting formed, right? So this is called aryl nitrine. Aryl nitrine is getting formed, right? So this is the one that is getting formed, aryl nitrine. Now what next? The next is, once you got this kind of things, what is left in the process? The ring expansion along with alkoxylation, fine. And this alkoxylation, because till now we have not brought anything which can give, can provide a methoxy group, right? So, and the methoxy group can come from, we all know about, from an alcohol, because we all know the nature of alcohol. Alcohol is acidic in nature. Now, since it's an acidic in nature, it can release what? The methoxy moiety, fine. And my intention is to make what? Methoxylated azepine, right? So what will happen? So once I am charging this with this methanol, so what will happen? This ultimately leads to the formation of what? This will remain same, but here actually no. Okay. Either this or there is a possibility that you won't get the hydrogen of nitrogen, fine. Instead the hydrogen of nitrogen you won't get, right? You can get methoxy will occupy the same place. Only thing is that there is a rearrangement of what? Rearrangement of electrons, right? So that's what we can say. This is, if I say 2-methoxy, like your 1, 2, 3, 4, 5, 6, 7. So this is the area which is found to be hydrogenated. Fine. If you observe that this is the area which is found to be hydrogenated, then obviously 1, 2, 3, 4, 5, 6. So 6H, 2-methoxy azepine. So this is found to be the substituted, what we can say, the substituted azepine which is getting formed, okay, once the reaction is over, right? Either this or this, but here this is found to be the highly predominant. So this one is the predominant one. This form is predominant one, right? This form is, if I just go from this way, so this is found to be 3H, or if I go from this way, this is found to be 6H, right? Because 1, 2, 3, 4, 5, 6. So this is the area, as there is, this is the area which is in the form of CH2. So that is why I'm using the term called either 3H or 6H. If you are considering this as 3H, then we can say this will become second, right? This will become 1, 2, 3, 4, 5, 6, 7, 7-methoxy. And if I just consider this as 6H, so what will happen? This will get the 2-methoxy. Fine. So thus we can write like the product is found to be, if I say this is 2-methoxy, so this we can write here 2-methoxy. 2-methoxy, then your 6H azepine. So this is the one that is getting formed once the reaction is over, right? So here what we did, actually we have taken nitrobenzene, and this has been charged with tributyl phosphine. So there is the formation of what? Nitrile, obviously aryl nitrile, but here aryl is nothing but benzene nitrile actually. Aryl, here we have taken aryl as benzene actually. Aryl as benzene, fine. And this need to be treated with methanol to produce what? Methoxylated azepine. So though it is getting formed, but this is getting transformed into this form, right? Where you observe that this location is getting hydrogenated, and thus we got what? Methoxylated azepine. So this is found to be the derivative of azepine. So hope you hope things are found to be clear. Okay. If you observe and you observe that how this azepine can be formed, at the same time substituted azepine is formed, right? So hope you like this video, right? And as I said always, please put your comments so that both of us can grow. So see you in my next video. Thank you.